One of the most important developments in abrasives technology has been the emergence of man-made superabrasives like diamonds and cubic boron nitride. Cubic boron nitride, or CBN, is the newest superabrasive, and next to diamond, it's the hardest material known to man. In fact, it's 2.5 times harder than aluminum oxide and other conventional abrasives. CBN is designed for grinding ferrous material and is generally used where conventional abrasives have difficulty or where tight tolerances and high precision are required. Diamond is designed to grind carbide, glass, ceramics, stone, and other non-ferrous materials. The difference between superabrasives and conventional abrasives can be likened to power saw blades. A regular steel blade tends to dull quickly, especially if it's cutting dense material like pressure-treated lumber. A carbide-tipped blade, however, cuts the same material easily while retaining its sharpness. The result? A long-lasting, truer-cutting, time-saving tool. The same applies to superabrasive wheels. They grind faster, cut more precise, and last considerably longer than conventional wheels. Superabrasive grinding wheels make the operator's job easier because they require less effort and produce top-quality parts at the lowest total cost. More and more shops are discovering this fact about superabrasives. They're also discovering that diamond and CBN wheels generate very little dust, require dramatically fewer wheel changes, and save both time and money. Yet, despite their obvious benefits, superabrasives are somewhat misunderstood. Why? Because of misconceptions about their preparation and maintenance. Generally speaking, superabrasives require a little more initial attention than conventional wheels. But that attention has to do more with technique than anything else. In fact, superabrasive and conventional wheel preparation have more in common than most people realize. In this program, we'll demonstrate superabrasive wheel preparation, and you can see for yourself. Like any grinding wheel, superabrasives require a certain amount of preparation before they are used. This preparation consists of 2 steps: truing and dressing. Truing is the process of shaping and forming a grinding wheel. Dressing is a separate step that exposes the grit and sharpens the wheel. Let's look at both steps, starting with truing. Truing changes the shape of the grinding wheel. It creates a round, concentric wheel, which is necessary for good grinding wheel performance. There are 4 methods for truing superabrasive wheels. The first 3, lapping, grinding, and brake control truing, can be used for both diamond and CBN. A 4th method, diamond nib truing, is only used on CBN wheels. Let's look at each method, starting with lapping. Lapping involves rotating the wheel face over loose abrasives. It can be done by machine, as shown here, or performed by hand. Another method is to grind the superabrasive wheel with a conventional wheel. The key to this operation is to run the superabrasive wheel at a relatively slow speed and the truing wheel at higher speed. In this example, the wheel is running at 200 surface feet per minute, and the truing wheel is running at 6,500 surface feet per minute. The slow work speed of the superabrasive wheel allows it to be ground by the conventional abrasive. A general recommendation is to traverse the wheel at 10 to 20 inches per minute at an INFEED rate of 1/1000th of an inch radially per pass. The most common method for truing a superabrasive wheel involves a brake control or motorized truing device. Another common method for truing CBN is diamond nib truing. We'll demonstrate these methods in a few minutes, but first, let's look at the second element of wheel preparation, Dressing. Dressing should always follow truing. After truing, a wheel face is closed and not ready to grind. Dressing erodes the wheel bond on the newly trued wheel, exposing the sharp abrasive grit so the wheel will cut. The procedure requires the operator to aggressively force a dressing stick into the wheel face. It's important, however, to stop dressing when the wheel begins to effortlessly wear the stick away. Don't overdress. You have to expose the grit, but not change the wheel face in doing so. You also have to leave the grit properly supported, otherwise it may fall out. The stick you use should be 1 or 2 grit sizes finer than that of the superabrasive wheel. In addition, you should expect to use at least half a dressing stick to open the wheel. In fact, you could easily use an entire stick for this process. Let's put the 2 wheel preparation elements together with the help of Norton training manager Norm Boylard.
The first step in truing a superabrasive wheel is to remove it from the box and mount it on the arbor.
It's not uncommon to find between 2 and 4 thousandths of total runout when you first mount the product. This can be caused by a worn arbor, so make sure to inspect your equipment carefully.
You could begin truing this wheel without further adjustment. However, you'd be wasting a lot of expensive grit by doing that. So it's best to put the wheel as close to truth as possible before actually truing it. Here's how.
First, hand tighten the nuts on the arbor. Then, using a dial indicator, rotate the wheel by hand and check for runout. Using a stick and mallet, gently tap the wheel until you have minimized the runout. By repeating this process of checking with a dial indicator and tapping the wheel, you should be able to reach a minimum runout of about 1/1000th.
Once this is finished, tighten the flanges completely. The wheel should not be removed from the flanges again, unless, of course, you want to repeat the whole setup process.
These are Norton truing devices, a standard brake control truing device, a large brake control truing device, and a motorized truing device.
The most common is this brake control device. It gets its name because of a braking mechanism located here in the back. When this wheel comes in contact with the spinning superabrasive wheel, it spins as well. And if it were to spin at the same speed as the superabrasive wheel, there'd be no grinding. So the back end of this unit contains brake shoes which expand by centrifugal force. The resulting braking action causes a 6-to-1 differential between the 2 wheels, which in turn causes grinding. Here's how it looks.
Once the grinding wheel is running, position the truing device directly under the superabrasive wheel and give it a spin counterclockwise. Then lower the superabrasive wheel until the 2 make contact. The brake control truing device should move quickly across the wheel face, up to 20 inches per minute on the cross feed. The down feed into the wheel can be between 1 and 2 thousandths. A good method for checking your progress is to run a crayon over the superabrasive wheel prior to truing. Then as truing progresses, you'll have a visual indication of where the wheel has been trued and where it hasn't. An additional check is to place a square on the wheel face itself. That will tell you if the wheel face is flat or whether it is slightly convex.
Since the superabrasive wheel drives the truing wheel, when initial edge contact takes place between the 2, a convex shape can result in the superabrasive wheel. To correct this situation, occasionally feed the truing device up into the center of the wheel face and out to the sides.
A successfully trued wheel has a flat, smooth surface with both grit and bond on the same plane. To effectively grind, the grit of this wheel must be exposed. That process is called dressing.
Dressing utilizes this, a dressing stick. It's essentially a stick of abrasive material which, when pushed into the wheel face, erodes the bond surrounding the grit. Your objective in dressing is to erode enough bond so the grit can cut, but not so much bond that the grit will loosen and come off. You also don't want to change the geometry of the wheel face, so proper dressing is important.
Successful dressing comes from using the proper dressing stick and applying it correctly. The stick should be at least as wide as the wheel face you are dressing. It should also be the correct abrasive type, generally 38A or 39C, around H or I grade. Use a stick 1 or 2 grit sizes finer than the super abrasive wheel. Now, apply the stick aggressively, enough to erode bond and expose grit, but not change the shape of the wheel face. Notice that the stick is being rotated as it's applied. This technique keeps the dressing stick from eroding only part of the wheel face. Notice also the amount of dressing stick being applied. In this case, you should use about 3/4 of a stick when dressing. Another indication that the wheel is properly dressed comes when the dressing stick feels as though it's being pulled into the wheel face. To help reduce dust, dip the dressing stick into your coolant before dressing. The resulting wheel face is shown here. Notice the difference between this and the shiny smooth surface of the newly trued wheel. As you can see, the grit is fully exposed, offering a satisfactory cutting surface.
The procedures we've just demonstrated are for all diamond and CBN wheels except Process E wheels. Process E wheels should never be trued and only dressed by a knowledgeable person. There's another technique for truing CBN wheels. It involves the use of a diamond truing tool called a nib.
A nib is a multi-point fine grit diamond tool. You should never use a single point tool to true a CBN wheel. The diamond nib's advantage is that it uses a diamond to cut, and it will give you a very flat wheel face. Its disadvantage is that it can actually flatten and damage the CBN grits, so proper technique is important. This process is done wet, and it's very important to pay close attention to the INFEED rate. 2/10,000ths of an inch or 5 microns is generally recommended. That's a fraction of the INFEED rate used for conventional abrasives. By maintaining a small INFEED rate, you can avoid damage to the wheel, obtain maximum wheel roundness, and also keep CBN grit loss to a minimum. Remember, it's important to check the trued wheel with a square to ensure the wheel face is absolutely flat.
Once truing is complete, dress the wheel as before. Once these procedures are followed, the super abrasive wheel should give you a long, productive life.
In summary, it's important to remember that while super abrasive wheels do grind better than conventional abrasive products, they need to be conditioned. That conditioning is a two-staged process called truing and dressing. Remember, truing changes the shape of a super abrasive wheel, creating a round concentric wheel with a flat, consistent grinding surface. Dressing erodes enough wheel bond to expose the cutting grit without changing the shape of the wheel face. In fact, if a wheel doesn't cut, it probably needs to be stick dressed. Utilizing these simple techniques will give you a CBN or diamond super abrasive wheel with excellent geometry and exposed sharp grit. And if the wheel is properly trued and dressed, it has to cut. To provide you with the best tools to do the job, Norton Company offers a complete line of super abrasive products. Diamond and CBN super abrasive grinding wheels and dressing sticks, truing devices for tool rooms and job shops, diamond rotary truing devices and cutters for production grinding, and automated dressing devices for job shop and production dressing. Norton CBN and Diamond super abrasive products are designed to increase productivity, reduce costs, and provide you with the best tools to do your job.